Okay, good morning, everybody. So just continuing from where we left off last day, we're going to start today by talking about the organization of a Java program, and then we're going to start to implement some classes of our own. All right, so what does a typical Java program look like? So you've been working with fairly small programs so far in your assignments. A typical Java program consists of one or more files. A large Java program might consist of literally thousands of files. At the top of every file is usually, there's always 0 or 1 package name. Again, in a typical professionally created piece of software, there will always be a package name at the top of every file. Then you'll have 0 or more import statements. So if your class requires the facilities of other classes, it may have to import those other classes. And then inside the file is typically one class. That's not a fixed rule. You can put more than one class inside of a file. You can put a class inside of a class, but typically there's one class inside of a file. Okay, and then inside each class, there's one or more fields. So a field is just a variable that belongs to the class. There will be these things called constructors, so 0 or more constructors. You've used a constructor or constructors in the course, or we've seen them anyway, seen the use of a constructor in the course. A little bit later on, we're going to implement one. And then you'll have 0 or more methods. Typically, there's more than 0 fields, there's more than 0 constructors, and there's more than 0 methods. Right? Okay, so there's a picture of what a class looks like. The actual text in the picture doesn't matter. Right? It's just showing you the layout of a class. Right? So at the top, you have a package, followed by some import statements, followed by the class itself. Inside the class itself, typically you see the variables that the class uses at the top of the class. Then you see the constructors, and then you see the methods that the class provides. So this file is available to you if you have the source code that the course uses, right? And it's actually much more complicated than this, but we don't get much more complicated than this in this course. In a real Java program, or I guess in a professional piece of Java, a professional Java program, there can be many other features. So you have things like static initialization blocks, non-static initialization blocks, and so on and so on and so on and so on. There's a little, the official Java tutorials, if you follow that link, describe or at least point out many of these features. Okay, so we're going to start out with a package because that's the thing that's at the top of your file. Right? So packages, the easiest way to think about a package is it's just the directory structure that Java imposes on your program. So the Java compiler expects to find your Java files in certain places. Right? And the places that it expects to find them in is determined by how you name your packages. So here the slide says a package is used to organize Java classes into namespaces. Most of you probably don't know what a namespace is. So it's a programming thing. So a namespace is just a container for names. So you can have a namespace. Inside the namespace, there's some names. Each one of the names is also a namespace. So inside that can be some names. And that sounds exactly like your directory structure or your folder structure on your computers, right? If you're in Windows, you've got a documents folder. Inside your documents folder, you might have your coursework folder and so on and so on and so forth. It's the exact same thing with packages. So packages are used to organize related classes and these things called interfaces. So you can, so for example, if you look at the standard library classes, you'll find them all in this package called Java. Right? So whoever created the Java language also provided you with a standard library of classes. All of those classes live in this package called Java. So whoever created the library on their computer, there's a folder called Java. And a package can contain packages. So inside the Java package, there's a package called lang, there's a package called util, there's a package called io, and so on and so on and so on and so forth. Right. That's just like your folder or directory structure on your computer. Right? So because you can have a package inside of a package, right? So we've got a package called lang. The full name of the package called lang, or the fully qualified name, is just all of the packages stuck together using periods separating the packages. So the full name of lang is actually java.lang. The full name of util is actually java.util, and so on and so on and so forth. On the, whoever has the Java standard library, in the source code for the Java standard library, on their computer, there's a directory called Java. Inside that directory or folder, there's another folder called lang, right? And so on and so on and so forth, right? So inside their Java folder, there's also a folder called util, and inside their Java folder, there's also a folder called IO, right? And so if you look at the source code that's provided with the course, so this is the project containing all of the Java source code that accompanies the notebooks. You'll see that inside, there's packages that are named ca.queensu.cs.sys124, blah, 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 blah. Right? The package names are very long. If you look on my computer, because I have the source code installed on here, there's the Eclipse project. Inside the Eclipse project, there's a folder called source, right? And inside the source folder, you'll see there's a package called ca. Right? And so ca here corresponds to the package ca over here. Right? Inside ca, you'll find queensu, so that corresponds to the second name in the package structure. Right? Inside queensu, you'll see cs, and inside cs, you'll find sys124, and then finally, you'll find notes, and then here you'll find a bunch of other packages. Right? And so we're going to be working in the basics package today, and inside that package, there are more packages. Right? And so your package structure is reflected in the directory structure containing your files. Right? And so the directory structure is meant to organize your files into, well, they're meant to organize your files. Right? Okay, so packages are allowed to contain, so a package can contain a package, but it can also contain classes. So for example, Java lang contains the class string that we talked about a few lectures ago. Java util contains the ArrayList class, and so on and so on and so forth. The math class is also in java.lang. Oh, so just like with packages, the full name of a class includes its full package name, followed by the name of the class, everything separated with periods. So the full name of string is java.lang.string, right? And you can always use the full name wherever you want, right? It's awkward, right? So it's it's a lot to type in, but you're always allowed to use the fully qualified name of a thing in Java. Okay, so ideally, packages are supposed to be packages are supposed to ensure that the fully qualified name of a thing is always unique, right? And so the class string, which is fundamental to the Java language, is defined, its full name is java.lang.string, right? Now there's nothing from stopping you from making your own string class if you wanted to. So you might say, look, Java's string class, it's too slow, or it doesn't do what I want it to do for my particular purpose. I'm going to make my own string class. You're still allowed to call the class string. You have to put it in a different package because your string class has to have a different fully qualified name compared to the Java standard string class. Otherwise, you can't use both classes in your program at the same time. Right? And I don't think you're allowed to put anything in java.lang anyway. So for example, you could create your own package called your, and then inside that package, you can define your own string class called string. Right? And now everywhere you want to use your string class, you write your.string. Everywhere you want to use the standard string class, you just write string. Right? And so now you can have two classes with the same name that exist in the same program. And so this allows the Java compiler to figure out, okay, which class do you mean when you say string, right? Here we mean your.string, here we mean java.lang.string. Right? So that's the idea behind packages. They give things a unique name. Okay, so if that's the purpose of packages, there's a question as to how do you actually guarantee that fully qualified names are unique, right? So one of you can go out and make your own package. You're allowed to name whatever you want. There's nothing stopping you from naming your packages the same as somebody else, right? And so there's nothing in the language that forces the fully qualified names to be unique. Right? And so instead, we have to rely on some convention for packages. And so the naming convention in Java is that packages should be organized using your organization's domain name verse. Right? And so the computing science domain name, this is the internet domain name, is cs.queensu.ca. And so the rule is you're supposed to flip this around backwards, so write the pieces of your domain name in reverse to get your package name. So here we have ca.queensu.cs, right? And that explains the naming convention that I've used for the 124 source code, right? So ca queensu cs 6124 blah 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 blah. Right? Now, internet domain names are guaranteed to be unique because there is one organization that oversees all of the domain names in the world. And so there is a central authority that can guarantee domain names are unique. So if you follow this convention, this guarantees that your package names are unique. Right? Obviously, for individual programmers doing their own thing, you may not have your own internet domain. You just pick whatever package naming convention you want to use. Right. Okay, so that's packages. Hopefully that explains a little bit about why the code that you've been using in the assignments is organized into packages the way that it is. We don't use the full package naming convention name. It's just a little bit too awkward to use for assignments. And so I typically just use A1, A2, A3, assignment 1, assignment 2, assignment 3, and so on and so forth. All right, so we've got packages. So you can, oh, I guess I should show you how to make a package in Eclipse. Okay, so in Eclipse, if you wanted to make a package, so I'm just going to go to the lectures project. You go up to your source folder, you right-click or you go to the file menu and you do new, and then you just say new package, like that, and it pops up this little window and it says, hey, what would you like to name your package? The naming convention for packages is that everything is in lowercase. You don't use lower camel case the same way that you use for variable names. Everything's in lowercase. You are allowed to use numbers, and you are discouraged from using anything else. So if I wanted to make a package for today's lecture, I might say something like, call it classes or something like that. And then you just click finish, and over here, a new package will pop up over here. Right? And then you can put whatever else you want to put into the package. Okay, so a class is just an implementation of a type, right? So it's Java's way to let the programmer create new reference types. Most often, a class is used as a blueprint to make instances of the class, right? So the purpose of most classes is to make objects. So if you make a class called myClass, the purpose of that class is to create objects of type myClass. Okay? So classes are user-defined types. Right? So why do you want to have objects? Because every object gets its own copy of all of its non-static fields. Right? And so if your class has some variables in it, and you don't mark the variables as being static, then every object gets its own copy of those variables. Right? So all of those variables are called fields. Right? Your objects get their own copy of all of these non-static fields. Right? And so this allows individual objects to have their own independent state. Right? So you can create a list, it has 5 things in it. You can create another list object, it has 10 different things in it. Right? And the 2 lists live independently of one another. Right? So today we're going to make this class called point2. So point2 is just a 2-dimensional point, which hopefully you've all seen in math class at some point in some time. Right? So it has an x and a y coordinate, and the coordinates are supposed to be real numbers. So we're going to use something like double or float to represent the coordinates of our point. Right, so here's a little example of a memory diagram showing 3 different points. Okay, so remember when you make any object, you're going to use the keyword new, right? So the new operator calls a constructor. So here we're going to call the point2 constructor. And it looks like our constructor takes in 2 values, and it turns out they're the x and the y coordinate of the point to create. Right? Count the number of news, right? You've got 3 news here, so that means there's 3.2 objects somewhere in memory. So they're over here. So 1, 2, and 3. Right? Again, it doesn't matter where you put them. I just stuck them at 600, 700, 800. It doesn't matter. Put them wherever you want. Right? It turns out every point object gets its own x and y coordinate. Where's the class? Here it is. So there's the point2 class itself. So the first time you use a class in Java, the class itself gets loaded somewhere into memory. Right? And so if you look inside the point2 class here, you see there's a variable x and there's a variable y. And so this means every point2 object has its own x and it has its own y. Right? So over here, when you write new point2, we make a copy of this class, right? So we use the class as a blueprint to make an object. So we make a new empty object up here, right? The constructor fills in the values of x and y with 1 and 2. Right? The second constructor call makes a new point object by copying the class, right? And it fills in the x and y coordinates to -3 and 8. Right? And finally, the third constructor call copies that class to make the object, fills in the values of 5 and 13. Right? You now got 3 separate points. They all have their own x and y coordinate, so they all have their own independent state. Right? If you ask that point, what's its x coordinate, it'll tell you 1. If you ask this point, what's its y coordinate, it'll tell you 8, and so on and so on and so forth. Right? If you change the x and y coordinates of the third point, the other 2 points are unaffected. Okay, so we would like to implement a class of some kind. And so for the most part in this course, we implement what are called value type classes. So a value class is just a class that represents some kind of value. Right? So for example, a name would be a value. Right? A date could be a value. Color could be a value. A point or a vector could be a value. Right? So for a name, you might use a string. You might think of that as being a name. Right? The class date, javautil.date, corresponds to a date. What is the color class is java.awt.color, I think. And the point is, well, we're going to make the point. So we're going to make a class called point2. So when you implement a class, it's, you have to decide what information do your objects need. So once you've decided what information your objects need, those typically become the variables belonging to your class, right? So basically the idea here is you need to decide what variables you need to represent the state of every object, right? And those variables are called fields in Java. That's not the object-oriented programming term. Object-oriented programming, in general, you see it, they're called attributes. Java calls them fields. So we're going to cook up this point2 class, and so we need to decide what fields do we need to represent a 2-dimensional point. Right? And so the hard part about designing classes is that there's never one answer. So there are many different ways that you could choose to represent a 2-dimensional point. Right? And your decision affects the rest of your class. Right? So once you decide, I'm going to use these variables to represent a point, all of your constructors and methods are now going to use those variables. So the decision of what types you use for your fields impacts the rest of your class. And so the hardest part about designing a class is deciding, okay, what do I actually need? What information actually needs to go into this class? Right? So for a 2-dimensional point, the answer seems obvious, right? We need something for the x coordinate. We need something for the y coordinate. So it looks like we could do this, the obvious way is to do this with 2 separate fields, right? One for x, one for y. Okay, so to write a class, right? Define a package if you want to, right? If you're just doing this on your own, you don't have to make a package, right? So if you're making up a little class to try something out, creating a package is unnecessary, right? For the purposes of this course, everything is inside, this point class is inside this set of packages here. So once you've got your package, you declare the class. So you have to say, this is the class that's going to be inside this file. And the way you write that is with the keyword class, right? And then you give your class a name. So remember, reference types, they always should start with a capital letter. So here, my class name is Big P point 2, right? The rule for naming classes is that you should use upper camel case. So the first word of the name is capitalized. If your name consists of multiple words, every subsequent word is also capitalized. Right? You are allowed to use numbers in the name, but they can't be the first character in the name. You're also allowed to use the underscore, but you are discouraged from using the underscore unless you have a good reason to do so. Right? So basically, English letters, numbers, if you use only English letters and numbers, you would be fine. Right? So class point 2 says that the class point, this file defines the point 2 class, and then you have the braces. There's no semicolon after the last brace. So the body of the braces define the body of the class, right? So all of your class implementation is going to go in between that brace and that brace there. Public means that any other class can see the point 2 class, right? And so that means anybody else can use this class if you make it public. We'll talk about other access modifiers later on. Okay, we now need to pick some variables to represent the x and y coordinates of the point. And so the description of the class says it's a Cartesian point in 2 dimensions having real coordinates. So if we're having real coordinates, we probably need to use double or float for our types for the x and y coordinate. So double x says that there's a variable of type double whose name is x. Double y says there's a variable of type double whose name is y. Right? Notice that these are not inside of a method or constructor, right? They are inside the class. Private means that the name x and y, they are not visible outside the class. Right? So public class point 2, anybody can use the point 2 class, but nobody can see the x and y coordinate directly. Right? So if someone has a point, p, they're not allowed to write p dot x to get to the x coordinate. They have to do something else. Right? So that's what private means. Private means only the class can use these values by name. Typically, when you make a class, your fields are private. There are other access modifiers that we'll talk about later in the course. Right? But for now, when you're making a class, you probably want to default to the private access modifier. You can always change it later on if you decide you need to increase the visibility of your fields. But for now, we want to make everything private. Right? And later on, we'll talk about why you might not want to make them private. Okay, so what we've created here, this is a fully functioning class at this point. So you can actually use this class if you wanted to in the way it's written. Right? And so what we have here is what's called a top-level class. Right? And so a top-level class is a class that is not inside of another class. Right? So point 2 is not inside of another class. Therefore, it's a top-level class. Right? So a top-level class is allowed to have the public access modifier. So that's what that means right there. Right? So the word public is what's called an access modifier. It controls the visibility, in this case, of the class. Right? So top-level classes can be public, which means the class is visible to all other classes everywhere. It is allowed to have no access modifier. So if you strike the public from here and just write class point 2, that's called package private access. Package private access means the class is visible only inside of the package it's defined in. Right? So if we were to strike public here, the only place you could use the class point 2 would be inside the geometry package here. If there was a package inside of the geometry package, you could not use the point 2 class there. Right? If you're in the basics package, you can't use the point 2 class if this thing is package private. right? So package private means class is visible only inside the package itself. So this concept of visibility is new for most of you, I think, right? So Python does not have this kind of, does not have an access modifier of any kind, right? So once you create a type in Python, that type is visible everywhere. Java lets you restrict the visibility of a type, right? And there are good software engineering reasons why you might want to do so. You can also have access modifiers on the fields themselves. So here we've marked everything, we've marked the fields as being private. Right? Fields have 4 different access modifiers. So private means visible only inside the class itself. Typically, that's your default choice for access modifier. Right? If you have no access modifier, so if we had just written double X and double Y, that means package private access. So again, the fields are visible to any class inside the same package. Right? And so what that means is any class inside the geometry package can now access the fields X and Y of a point directly by name. Right? So if they had a variable P that was a point2 object, they can then write P.X and get access to that field. Right? They can write P.Y and get access to that field. Protected means the same thing as package private, but it's also visible to these things called subclasses. We'll talk more about that in probably 5 weeks or so. Finally, public means that the field is visible to all classes everywhere. And so if we made this field public, so public double X, public double Y, we could change the value of X and Y from everywhere. And I guess at this point, this is a good time to play around with these access modifiers and try to see what they mean. So inside the geometry package, I'm going to make a new class called test. Right, and when I'm going to try to play around with the fields of a point. So I'm going to make a little main method. I'm going to make a point. Oops, sorry, point 2, P equals new point 2. Okay, if you write something like that, it turns out that makes the point 0, 0. I'm now going to try to change the value of the X coordinate of the point, like that. Right? So when I write that, notice you get a little red X over here, and it says the field point2X is not visible. Right? And so what is it complaining about? It's complaining that we've marked the field private. That means it's not visible outside of point 2. So the class test cannot access the X coordinate directly. Right? And so that's your error there. Right? If you try to run this program, it won't run. It won't compile. Right? Okay, so what if we strike the access modifier like that? Right? So if we strike the access modifier on X, it's now package private. Test is now happy. Right? T.X is now modifiable by the class text. Right? Why? Because test is inside the package, the same package that point 2 is. So it can see the field X belonging to point 2. Right. What if we make it protected? Okay, inside the same package, it means X is visible. It means the field X is visible to classes inside the same package. I'm not going to bother showing the subclass. We'll talk about that later on. And let me go into a completely different package. So I'm going to go up to what's called the default package. Which is basically no package. And I'm going to modify hello world. I'm going to make a point2 object. Right, so I'm now outside of the package that the point2 class is defined in. So now that I'm outside the package that point2 is defined in, I have to import the package. I have to import the class. Right. So here, I have to import point2, and I have to pick the right one. So it turns out it's this one. So it's the basics one. Right? So that works fine. I've imported the class. I can now use the class. I'm going to try to change X like that. Okay, so it complains. Right? It's going to say point2X is not visible. Right? Go back to point 2. Right? It's protected. That means the field X is only inside the package itself. Right? But if I make it public, right, I can now change X over here. right? And everything is fine. So if you make your fields public, any class anywhere else can change the value of that field. For many classes, you don't want that to happen, right? And so we'll see lots of examples of that later in the course. Okay, access modifiers on fields. So the safe rule of thumb, right? If your class defines a value that is a constant, and you want everybody to be able to use that constant, you should make it public, because you want everybody to use that constant value, right? It's constant, so you don't worry about the value ever changing, right? So for example, java.lang.math has a constant called pi, right? It's public, so everybody using the math class gets to know what the value of pi is, right? You don't have to define your own value for pi every time you want to use pi, right? The rule of thumb is that if it's not a constant that you want other people to know about, make it private, right? And so that's the safe rule of thumb, which is what we're going to follow for the time being, right? Protected fields show up later when we talk about inheritance. Package private fields show up a little bit later, also when we talk about inheritance. Okay, so we've got point 2, pretty easy, right? Declare the class, pick your fields, and away you go. So let's try a slightly, no, this is an easier class, I guess, right? So now I want to make a class that represents a simple mechanical counter, right? And so it's basically a device that starts at 0, and you can count upwards in increments of 1, right? So 0, then 1, then 2, then 3, and so on and so on and so forth. Okay, so we want to implement this class. First question that you ask is, well, what variable or variables do I need to represent a count, right? Well, it looks like these are integer counts, so I probably need a field of type int or long or something like that. And it looks like I only need 1, right? There's no maximum value, there's no minimum value, we're not incrementing in steps other than 1. So it looks like we can get away with just 1 field. Right? Okay, so inside the basics package, there's a package called, is that true? Is there a package called basics? No, there is, okay. So there's a package called counter. Inside that package, we write public class counter, right? Again, notice the big C on the counter, right? Upper camel case for class names. What variables do we need? Well, I need a value. What is its type? We're going to use int. So our counter class can count incrementally upwards from 0 up to integer max value. Right? We're going to choose our default access modifier of private, and that's it. You've got a counter class that would actually work at this point in time. You can't do much with it, but you can actually make a pointer counter object if you wanted to. I should change this. Well, I guess we're here, so I'm going to go with this for now. In the next lecture, I meant to change this for this term, but we're going to go with this. All right, so we want to implement a stopwatch now. So this is actually a fairly complicated example for a first lecture on how to implement a class. Okay. So the idea here is that we want to implement a class that represents a stopwatch that the user can start and stop. Right? So when you press start, it starts to keep track of how much time has elapsed since you pressed start. Right? When you press stop, it stops keeping track of how much time has elapsed, and you can look at how much time has elapsed. Right? Similarly, once you press start, you can look at how much time has elapsed, right? And it tells you 1.5 seconds have gone since you pressed start. Right? So implementing this thing is not so obvious, in particular because you don't know how to get time from Java. And so I have to tell you a little bit about how you can actually get time from Java. Okay, so to get the current time, there is this method called system.nanotime. Right? So nano implies nanosecond, and so a nanosecond is 10 to the minus 9 seconds, right? So it's a very small amount of time. So this method nanotime gives you the most precise available system time in nanoseconds. So it depends on what computer you're running on, how accurate this value actually is. Now the problem with this is that it doesn't give you a time like 12:05, whatever, like Eastern Standard Time, right? Instead, it just gives you back a number. So it gives you back a long integer value, right? And that's the number of nanoseconds since some fixed arbitrary time, right? So in other words, all you do, what you end up getting back is some positive, some non-zero, some positive or zero value for the current time, right? And it's the number of nanoseconds since some point in time that you don't know, right? So if you want to know how much time has elapsed between two periods of time, you can call nanotime once. That gives you a start time. You call it a second time, and that gives you a stop time. And if you take the difference, that gives you the number of nanoseconds that have elapsed between the start and stop time. Right? And so that's how we're going to get time from Java in this case. Right? So we can get the start time, we can get the stop time. Those are probably going to be useful for our stopwatch class. Right? So our class is called stopwatch. We're going to get the start time, we're going to get the stop time. So I'm calling these raw start and raw stop because they're not true times, right? They're these funny nanosecond things that nanotime is giving us back. Right? Okay, I also need something else though. So the way this thing works is that you can press start, right? That starts the clock running, right? You can press stop, that stops the clock from running. So if you look at the stopwatch at some point in time, to get the accurate time, to get the true time that's elapsed, you need to know, is the stopwatch actually running or not, right? If it's not running, you're going to report the amount of time between here and here. But if it is running, you're going to report the amount of time from now relative to that time there. So you need to know, is the watch running, yes or no? So we need a third field here in this case, right? So we've got our is running field. When you're naming true, false values, the variables for them, typically you use a verb of some kind, right? So is running, right? Has next, something like that. Okay, so we've got three classes. They've got nothing but names and fields, right? That's it. But in their current form, you can in fact use them to make objects, right? So if you import all of these classes into some class called makeSomeObjects, right? You can make a point2 object, you can make a counter object, and you can make a stopwatch object, right? You can only do this using the no argument constructors, right? But this works. You can't do anything with them yet because we haven't defined any methods for the classes. But this works just fine. So you can make objects now, which is good. All right, so now we want our classes to be to actually do something. So we can now add features to the classes so that they now have some behavior or actions that they can perform. Right? So this is what methods are for. Right? So a method performs some sort of action or computation or behavior for your objects. Right? How do they work? Well, they have access to the fields of your class. And so that means a method typically uses the information stored in an object to calculate something. Right? So stopwatch, for example, is going to use its start and stop time to calculate how much time has elapsed since the watch was started. Right? You also want to make your classes easy to use for people. Right? So yeah, I can make a point2 object, right? But that point2 object is always 0, 0. Right? It might be nice if I can make a point2 object whose coordinates were something else. It would be nice if I could copy an existing point2 object, and so on and so on and so on. Right? And so we're allowed to define our own constructors that let us set the state of an object when it gets created using new. Right? And so I think in the last lecture we saw this term encapsulation. Right? So encapsulation just means bundling of data and methods that use the data into a single unit. Right? And so a class is one form of encapsulation in Java. Right? It's got variables, so there's your data. It can have methods, right, that work on the data. So all of the methods and information live in one place. It lives inside of a class. Right? Okay, so I guess we should start at the very beginning. So we've got fields. The next thing you normally want to do is you want to implement a constructor. Right? So remember what constructors do. Right? So when do you use a constructor? Well, you always use it with new. Right? There's no other place you can use a constructor. Right? You can't call a constructor without using new. Right? What does the constructor do? So new makes the object. The constructor initializes the state of the object. Right? So what is the state of the object? Well, it's just the value of its fields. So a constructor simply fills in the value for the fields. Right? So new makes the object, constructor fills in the value of the fields of the object. So when you make a constructor, Java is pretty restrictive on your constructors. Right? So constructors always have the exact same name as the class. Right? So the point2 class, all of its constructors are called big P point2. Constructors never return a value. Right? So the unfortunate part of Java is that constructors look like methods. The language specifically says constructors are not methods. Right? One of the reasons they're not methods is because constructors never return a value. Right? So not even void. So when you're writing your constructor, remember it's just the access modifier followed by the constructor name. Right? There's no void, there's no return type. Constructors aren't allowed to return a value. Right? And then your constructors can have 0 or more parameters. Right? Just like a method can have 0 or more parameters. Right? Okay, if you make a class and you have no constructors in the class, Java makes up a constructor for you. Right? Which is why this code back here worked. Right? Our 3 classes have nothing inside of them except for the fields, so there's no constructors defined yet. Right? If you're in this situation, Java makes up a constructor. It makes up the no argument constructor for you. Right? And it doesn't tell you it's doing this, right? So it silently inserts the no argument constructor for you. Right? The no argument constructor is the constructor that has no parameters, right? That's why it's called the no argument constructor. What is its purpose? It's supposed to, well, it's the same thing as for any constructor, right? It sets the state of the object, right? So when you make an object, you don't want it, well, you typically don't want it to have a random state, right? So when you make a point2 object, you don't want to get some random point2 object, right? Typically, you want it to have some well-defined state. So the no argument constructor sets the object to some pre-chosen, well-defined state. Right? Who chooses the state? It's whoever creates the class. Right? If you don't put the if your class has no constructors, you get the no argument constructor for free, and your constructor ends up doing the following. Right? If you have a field that is primitive, it gets set to 0 or false if it's a Boolean field. Right? If it's a reference type field, so if your class has a string inside of it, the field gets the value null, meaning no object. Right? And so that's what the no argument constructor does for you. And that means back here, right? So when you, let's go back here. So one more, here. So for our point2 class, right? If we use the class in this form, its no argument constructor sets x and y to 0. Right? For the counter class, its no argument constructor sets the value to 0. And for the stopwatch class, that gets set to 0, that gets set to 0, that gets set to false. Right? So that's nice. So Java synthesizes the no argument constructor for you as long as your class has exactly 0 defined constructors. As soon as you define one constructor, Java stops defining the no argument constructor for you. So if you want one, you typically have to put it in yourself. Right? So let's look at one example of a constructor, and then we'll call it quits for today. So our point2 constructor, I'm going to want to add extra constructors to the class. If I want the no argument constructor to exist, I have to define it myself. I would like the no argument constructor to make a point having coordinate 0, 0. You could choose something else, right? 1, 1, something else, right? I'm going to choose 0, 0. So what do you write? So there's our class. There are fields. Now you insert the constructor, right? Name of the constructor matches the name of the class, right? No argument constructor, so we have the round brackets, has no parameters, right? So nothing inside the round brackets. Access modifier here, public means any other class can use this constructor, as long as they can also see the class, right? So you write, so I want to set x to 0, I want to set y to 0, right? You can, if you want to here, write x equals 0, y equals 0, and away you go. That would be fine, right? Whenever you use a field in a class, though, you may use the word this in front of the name of the field. So you can write this dot x equals 0 and this dot y equals 0, right? That's the way I'm always going to write the code in the slides and in the notes, right? So when you see this dot x, you know immediately, oh, you mean the field x. And when you see this dot y, you know immediately you mean the field y, right? The word this actually has a very specific meaning inside of a class, right? So inside of a constructor, that word this is a reference to the object that's currently being initialized, right? So what the heck does that mean? So remember, when is a constructor called? Well, you write new blah, right? New constructor. So new makes an object, right? New, that's the job of new. Inside the constructor, the keyword this is a reference to the newly created object, right? And so that lets Java fill in the values of the correct object, right? Because it has a reference to the thing that just got created. So it can find the object, fill in its x coordinate to 0, and it can find the object that was just created, fill in its y coordinate to 0, right? If you don't write this in front of a field name, then you, sorry, if you don't write this in front of a variable name, typically, sorry, not typically, I have to be careful here. In this particular case, if you don't write this in front of the field name, Java is smart enough to know you mean the field called x, right? So x.0, y.0 sets that x and y to 0. I guess in the next lecture, I'll show you an example where that doesn't work anymore. But for now, that's good enough. So there's your introduction to constructors and classes in Java. Okay. So we'll continue this lecture on Friday, I guess.